Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So in this class, we will continue solving problems on Fourier, cosine and sine transform. So let us take the problem, find the Fourier sine transform, Fourier sine transform of e raised to minus of mod of x, and hence deduce integral 0 to infinity x into sine mx divided by 1 plus x square with respect to x, where m is positive. So first we need to find the Fourier sine transform of a given function e raised to minus of mod x. Later, by using the answer of this first part, we need to deduce this second part. Since we need to find the sine transform, so we use a sine transform formula. So we have fs of u is equal to, it is integral 0 to infinity f of x into sine ux with respect to x. So in this, substituting f of x, so we have 0 to infinity, f of x is nothing but e raised to minus of mod x into sine ux with respect to x. And since we know that the function f of x has a mod x, and since we know that mod x will be always positive for the positive range and mod x will be always negative for the negative range, therefore here 0 to infinity is a positive range, therefore this mod x will be plus x, therefore plus into minus will remain minus there, so it is e raised to minus x into sine ux with respect to x. And since this is the simplest form to evaluate the integral, and we have a formula here, that is integral of e raised to ax into sine bx with respect to x will be equal to e raised to ax divided by a square plus b square into a into sine bx minus of b into cos of bx. This is the formula for the standard integral. So in this formula, a is nothing but, in this function, a is nothing but minus 1 and b is nothing but u. So replacing a as minus 1 and b as plus u. So therefore it becomes e raised to minus x divided by 1 plus u square into bracket a is nothing but minus 1 into sine bx, that is sine of ux, minus b is nothing but u into cos bx, that is nothing but cos of ux, applying the limits 0 to infinity. Now applying the limits here, and we have fs of u is equal to, first applying the upper limit is infinity, therefore e raised to minus infinity is 0, 0 into anything become 0 here. So coming to the lower limit, and while taking the lower limit we are going to take one minus sign here, so this is minus, lower limit is 0, so e raised to 0 will be 1 divided by 1 plus u square into bracket sine 0 will be 0 and cos 0 will be 1. So cos 0 is 1, remaining is minus u here. So therefore we have fs of u is equal to u divided by 1 plus u square, and hence this is the Fourier sine transform of e raised to minus of mod x. So obviously this is a sine transform. Now we need to deduce the second part, and obviously to deduce the second part, every time we are going to use the respective inverse formulas. So the respective inverse formula means we make use of inverse sine transform. So we have a inverse sine transform formula. We have inverse sine transform, that is f of x is equal to 2 by pi integral 0 to infinity fs of u into sine ux with respect to u. So this is nothing but 2 by pi integral 0 to infinity now. Now substituting the Fourier sine transform from the first half, that is u divided by 1 plus u square into sine of ux with respect to u. As we know, as I told in my previous classes, that in the second part we are not actually integrating, we just try to reduce that integral into the required integral form. So we just try to simplify it. So here obviously we are having u into sine ux with respect to u divided by 1 plus u square. When you just compare this integral, when you compare this integral with this, we come to know that in place of u we are having x. Obviously here x divided by 1 plus x square means here we are having u divided by 1 plus u square. So obviously when we see it, it look like that we need to replace u as x directly, but in this step we are not going to substitute, or we are not going to replace u as x directly. It is because if I replace here u as x, it becomes sine x square. Therefore what we need to do is, first in this integral, to reduce into this form, in this integral we replace x as m first, because here we are having sine mx. Therefore to get this m we replace x as m, replacing x as m, and it become f of m is equal to 2 divided by pi 0 to infinity u into sine of m u divided by 1 plus u square with respect to u. So we just replaced x as m. So when we replace x as m, we got u sine mu divided by 1 plus u square with respect to u. And what is f of m here? And since we know that f of x is nothing but, obviously here we are having f of x, it's a given function, that is e raised to minus of mod x. So if I replace this x as m, I get here e raised to minus of mod of m. Therefore f of m is nothing but e raised to minus of mod of m. And in this step only, replacing u as x. Okay, in this step only replace u as x. So we get x into sine of mx divided by 1 plus x square with respect to x. So here you just write a statement, replace u as x, and hence we get the required integral value. Therefore, finally we have 0 to infinity x sin f mx divided by 1 plus x square with respect to x is nothing but e raised to minus of mod m, and hence that's the solution. Let us take the next problem. Solve the integral 0 to infinity f of theta cos alpha theta with respect to theta, and it is defined as 1 minus alpha for all the values of alpha lies between 0 and 1, and the integral value is 0 for all the value of alpha greater than 1 here. The problems looks little bit different compared to the previous problem, but it is same as previous, but the presentation is different here. So to understand what exactly the given data is, I just write the formula, that is a cosine transform formula. We have Fourier cosine transform formula. Fourier cosine transform formula, that is fc of u is equal to, it is integral 0 to infinity f of x into cos ux with respect to x. So this is a Fourier cosine transform formula. Just comparing this integral with this formula. When we compare it, we just come to know that in place of f of x, we are having f of theta, and in place of cos ux, we are having cos alpha theta. So it's very simple, just replacing x as theta, u as alpha, and x as theta. So this integral is equal to this integral, but this integral is equal to fc of u. But in place of u, we are having alpha. It means that this function, what they define, it is representing fc of alpha. Therefore, comparing both the equations, we come to know that fc of alpha is equal to, it is defined as 1 minus alpha, where alpha is lying between 0 and 1. So fc of alpha or fc of u is representing a Fourier cosine transform. It means the cosine transform is given and we need to find its inverse, obviously. Okay, so inverse means we need to find f of x, but here in this particular problem, f of x is replaced by f of theta. So now we need to find f of x, that is inverse Fourier transform formula. So what is inverse Fourier transform formula here? That is f of x equal to, we are having a formula 2 upon pi integral 0 to infinity, we are having fc of u into cos ux with respect to u. This is the formula which is representing inverse cosine transform formula. But as I said, in this given problem, f of x is replaced by f of theta. It means x is replaced by theta, u is replaced by alpha, and x is again replaced by theta. So you need to replace those variables according to given in the problem. Therefore, what the f of x formula becomes? So then f of x formula becomes f of theta, because here in this problem x is replaced by theta. Therefore, this is f of theta is equal to 2 by pi integral 0 to infinity fc of u. Obviously u is replaced by alpha, so we have fc of alpha cos ux, and since we know that u is replaced by alpha, x is replaced by theta, so we have cos alpha theta with respect to alpha here, because u is replaced by alpha. So now substituting the function, so 0 to infinity, and since we know that fc of alpha is nothing but 1 minus alpha between 0 to 1. It means that instead of taking the limit infinity, we can take it as 0 to 1, because the alpha value is ranging from 0 to 1. So I will replace it as 0 to 1, and I will substitute the value for fc of alpha. So fc of alpha is nothing but 1 minus alpha into cos alpha theta with respect to alpha. Now we need to integrate it with respect to alpha. Okay, so when you are integrating with respect to alpha, definitely we treat theta as a constant, and here obviously there is a product of two function u into v. So whenever there is a product of two function u and v, and out of that product one function is a vanishing function, that time we use a Bernoulli's rule. What is a Bernoulli's rule? Bernoulli's rule is nothing but u into v is equal to u into v1 minus u dash into v2 plus u double dash into v3, and so on. So this formula we are going to use to evaluate the product of two functions. So it is 2 by pi into bracket u as it is now, and integration of cos alpha theta with respect to alpha will be sin alpha theta divided by theta minus derivative of 1 minus alpha with respect to alpha will be minus 1, and integration of sin alpha theta with respect to alpha will be minus of cos of alpha theta divided by theta square, applying the limits 0 to 1. So f of theta is equal to, it is 2 by pi in bracket, applying the upper limit 1 minus 1 will be 0, 0 into anything is 0, and since there are 3 minuses here, minus into minus become minus, and cos, in place of alpha you need to replace this upper limit 1, so it become cos theta divided by theta square. Now coming to the lower limit, sin 0 will be 0, so 0 into anything is 0. So minus into minus become 3 minuses will be minus, and since we are applying the lower limit, so one more minus will come, so minus into minus will be plus, cos 0 will be 1, so remaining is 1 by theta square. So therefore we have f of theta is equal to 2 by pi in bracket 1 by theta square, I will take common and it become 1 minus cos of theta, bracket complete. Therefore f of theta is equal to, it is 2 divided by pi theta square into 1 minus cos theta is nothing but 2 times of sin square theta by 2. So we can simplify it further. So f of theta is equal to 4 times of sin square theta by 2 divided by pi theta square. So I'll simplify it further so that I can use this answer to evaluate the next part. So it is f of theta is equal to sin square theta by 2 divided by, I will keep this 1 by pi as it is, and I will take this 4 in the denominator so that I can write it as theta by 2 the whole square. Okay, when I take this 4 in the denominator, it becomes theta square by 4. Therefore, theta square by 4 can be written as theta by 2 the whole square, and hence this is f of theta, which is required solution of this integral of the first part. Okay, so from the first half we got f of theta. So f of theta is equal to 1 upon pi into sine square theta by 2 divided by theta by 2 the whole square. So every time if there are two parts in this kind of problem, then definitely to get to evaluate the second part, we make use of the answer of the first part. That's why we have the answer in the first part as f of theta is equal to 1 upon pi into sine square theta by 2 divided by theta by 2 the whole square. Now we need to evaluate the second integral, that is 0 to infinity sine square t by t square with respect to t. And since we are having f of theta, therefore we use the formula for cosine transform. Okay, the formula of cosine transform. But just observe that u is replaced as alpha, x is replaced as theta. Therefore, the cosine transform formula, I will write it as fc of alpha is equal to, fc of alpha is equal to, it is integral 0 to infinity f of theta into cos of alpha theta with respect to theta here. Now just replacing this f of theta, we have the answer, that is 1 upon pi, I will take it outside, into sine square theta by 2 divided by theta by 2 the whole square, into cos alpha theta with respect to theta, and here we are having fc of alpha. And when we observe this required integral, in this integral we do not have any cos function, but here we are having that cos function. Then how to eliminate that cos function here? Obviously only one way, that is we need to make it 1. So how to make it 1? So in that case, put alpha equal to 0. So to make that cos 1, put alpha equal to 0, and we have fc of 0 is equal to 1 upon pi 0 to infinity sine square theta by 2 divided by theta by 2 the whole square with respect to theta. As we put alpha equal to 0 here, it becomes cos 0, and cos 0 will be 1. And now we need to get the integral sine square t by t square. And before that, what is the value of fc of 0? Obviously, we know that this is fc of 0. It is fc of alpha. So in this fc of alpha, we need to put the value of alpha, that is 0. So when you put alpha equal to 0 here, it becomes fc of 0. So fc of 0 obviously lies in this range. So when you put alpha equal to 0 here, then fc of 0 becomes 1. Therefore, fc of 0 is 1 is equal to 1 upon pi integral 0 to infinity sine square theta by 2 divided by theta by 2 the whole square with respect to theta, since we need to have sine square t. Therefore, we take a substitution here, theta by 2 equal to t, and therefore d theta will be 2 times of dt. So replacing d theta as 2 times of dt and replacing theta by 2 as t. And obviously the limits will remain 0 to infinity only. Therefore, I will cross multiply this pi, so we get pi equal to integral 0 to infinity, and it becomes sine square t divided by t square, and d theta is nothing but it is 2 times of dt. So therefore the final answer will be pi by 2 is equal to integral 0 to infinity sine square t by t square with respect to t here, and that's the value of the integral 0 to infinity sine square t by t square with respect to t, and hence that's the solution.